Welcome to this presentation on software releases. Promise it's not going to be a technical one. It's going to be more of a discussion. It should hopefully, help people to ask the right questions, and you'll get an idea as we go along. So basically, a couple of provisos before we start. There won't be any code, like I mentioned. I try to make some references to styling or CSS as we go along, but I'm definitely no expert on CSS, so anything which I say related to styling, please take with a very small pinch of salt. And answers are free, so please do ask. So, what's all the fuss about releases and versions? And why do we take releases? Any ideas? Why do we decide to actually say, let me release this component or this product or this library?
Because a certain version syncs with a certain section of code.
That's pretty much it. So we decide that a particular version is stable enough for us, and we want to freeze it pretty much. What's in a version? We'll see what the version describes. When we ask ourselves, why should I upgrade the version of a dependency? There probably would be a bit of a small train of thought. Do you think things might break? What should I do after I upgrade the version of the library? This kind of stuff. And, one of the comments that kind of we sometimes might think is just an internal library, we know what's in it, So the goals of a person or a team who maintains a software, which of course it's being released to an audience. So basically, the goals should be to release a well-documented and stable API of this library, to update this library with bug fixes and new features, or the software, keep it updated, and to, whenever possible, remain backwards compatible, so that we don't cause any pain to our users, and indicate when we're introducing breaking changes. So if we have no way around it, if we're changing the API, at least we inform our users of it. Basically, all of this should help keep a low cost for our users, which will increase adoption of our software and will make money.
Excuse me, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
So what are the goals of a software user this time? Not the person who maintains the software, but a person who is actually making use of the software. So basically, these people should be interested in getting bug fixes and new features from their library. They should know what features they're getting in any of the new versions. Hopefully they get no breaking changes, and if there are breaking changes, they get some instructions and the way around these breaking changes pretty much. So basically they get a low cost of use, decrease work, make money, and go to the beach. So, semantic versioning. I'm going to be mentioning this. So I thought about, just going quickly through the definition of semantic versioning. So basically, semantic versioning is a 3-digit versioning system where the first digit, the leftmost one, is the major version, which we should bump when we're making compatible changes. The minor version is the second digit, where we use to indicate that we are introducing new features, but we didn't break backwards compatibility. And finally, the last one is the fetch version. We're not introducing new features, we're basically fixing our bugs. So what's in a version? A version describes the current state of a project. The version difference would describe the expected type of change. So if, for example, we're going from, we're bumping the major version, we should have an idea of what to expect by that bump. And also the current version If it's a snapshot, it means that this project is not yet released. Which, as Xavier was saying, it means that it might change. And it will change without notice. So if you depend on a project which is a snapshot, that project might actually change under your feet without you noticing. A release version would mean that, of course, it has been released, so it will never change. And Maven assumes that it will never change. So if you try to change it somehow by deleting it from Artifactory or NPM or Bower repo, basically these tools will assume that the project is never changed. So if you have a local copy, it will remain the old copy. So please, if a project is released, don't delete it. What does a version smaller than 1 mean? It's usually a closed API. So if we can use this both for internal and as a guideline for external third-party projects as well. If it's smaller than 1.0, it usually means it's still a closed API. So it is released, but it can change. So pretty much the API that they have defined as a project, it can change. So basically, expect, ideally, you don't base a lot of your code around that API because it is bound to change. Usually a version bigger than 1.0 would mean that it is released to the public. So use with caution. If a version is bigger than 1, it should be a public and stable API that the maintainer should keep stable.
I think a version lower than 1, basically, it either means you can do breaking changes, or there'll be breaking changes all the time without actually upgrading the major version. It's always under 0, under 1, kind of.
The 0 point whatever would mean the API has not stabilized yet. So as the project matures, expect there to be changes. Either don't use or use in POCs, etc. I wouldn't base a lot of
work in progress, like it can have major or breaking changes without you, I don't know, without you being advised of.
Yeah, it's of course a guideline, so I'm not saying that all projects will be using it, but it's a good guideline and a lot of projects actually use it. Probably we actually are adopting it internally as well. I mean, once we feel confident with a particular library, we will bump it over 1.0. Any questions till now? I've been running a bit, going through the material at the beginning. Anything on the call?
Yeah, actually a question.
No.
So what's the difference between a version 1.0.0 snapshot and a version 0? I mean, if we adopt the 0.8, then when we want to release, we have to bump up to the 1.0.0 without snapshot because it's releasing.
Correct, yes.
In that case, we will not use snapshot.
So the question is, if I understand correctly, if an API is basically 1.0.0 snapshot, it means it's not yet stable. But if it's 0.9.0 release, it still would mean that it's not stable. Usually the version being lower than 1.0 would denote like maturity of the API. So the API of 0.9.0 will not change, but going from 0.9.0 to 0.9.5 or I don't know 0.10.0 means the API can change drastically. That's usually a guideline followed by third-party projects like this. So the changes would not be small. They might go through an entire refactor of the code if it's not yet mature enough. Did that answer your question?
Yeah.
Yes?
Determines a closed API. Who can use a closed API?
So by closed, sometimes open source contributors would work behind closed doors until they reach a 1.0 version and only release it after it's 1.0. Otherwise, they might decide to work entirely from the get-go in an open source fashion, so that external contributors can shape even the very beginnings of the project. But the version in itself give an idea that this is still, you know, in early stages.
So if we're using libraries internally, having a closed API, i.e. an API version less than 1, can be also a library, can be also anything. Does it mean it should be confined to one, to its originally intended component, or should people not touch it until it reaches a 1, or?
So the idea is that until you get a bit of a stable API, at least tested in one component, you wouldn't actually, you know, try and give your library to other people to use, other projects, etc. So the idea would be that you keep it in a very limited scope. Of course, you can disclose it so that others can get an idea of what you're working on, but the idea is that you don't say, hey, I have a polished product, I've named it 1.0, and then the API is still not actually even documented. So it's just a guideline, but it should give a bit of an idea of the current state of the project. It's a bit of a like an alpha or beta phase of your project. It's like, hey, I have this, I took a release of it, but you know, it can change. So it's not ready for production use probably, but you can of course do POCs based around it, etc. So the difference of a version, because we've talked about the current version of a product. So of course, if it's a major version bump, expect to have code changes. If your widget is, for example, if the software you're using is a third-party widget, it might change the HTML attributes, the name of the attributes. If it's an API, it might change the signature of the method. So if it's a major version bump, you probably would have to do changes. If it's a minor, it would include new features, but you shouldn't, in theory, be required to do code changes. However, there's new features which you might decide to use. If it's a patch version, no new features, just bug fixes. So the guidelines, yes?
Clayton, if it's a very small change, like removing an enum value, so it's a very small change, but it might break backwards compatibility because all of a sudden, whoever is using that value now, it's not available anymore. How would you categorize that?
If it's a breaking change, it's a major. I mean,
but even if all you changed was an enum value?
I wouldn't categorize a major as being something which, I mean, like by the number of lines of code which you have changed or anything. You could have refactored, you could have a project which has the implementation of the project is thousands of lines of code. You refactor entirely, but you don't modify the API. That would be categorized as a minor version bump. But if you change the API, me personally, the way I would think of a major is something which might cause others to do code changes.
I see. So you'd go with a major version bump anyway, even if it's such a small change. But since you broke or potentially broke other people's code.
Yeah, that's even like the guideline which are used in the like the manifesto of semantic versioning. That if your change will cause others to have to change their own code, then it should be a major one.
Thank you.
Probably something like removing enum value is tied into a much bigger problem, or a solution to something much bigger. For example, we're removing the pause state of a VM.
Yeah.
Might it be tied to a much larger?
It isn't directly tied to like it's an API change or you know. There are of course ways to mitigate.
Well, actually, we have a case in point right now on a task that Milica is working on. She's cleaning up old flows from the internal API, and somewhere in common, I think we're keeping an enums of the flows, and we're removing one of the flows. It's not being triggered by anyone, and in one of the repos, it was literally just removing an enum value. which in
I think
theory,
it was in email services.
email services. Thank you, Melissa. And my reaction was, okay, it's a very small change, but it could potentially break someone. So I went for the minor version bump. But you're saying since you could break code, even if it's such a small change, we'll still go with a major.
It's still a suggestion. I mean, like, the idea is that anything which would possibly break other people's code would be a major.
Shy away from actually using these numbers, because all they do is make a reference to what probably changed and what will be the cause of it. I mean, yes, it's called major. To be honest, it's something that it will cause me a breaking change, or it will cause me something that I need to change, basically. So, I mean, being named major, minor, patch, you know, sometimes it just misleads people into saying, like, as Alan, I mean, reasons it out. I mean, it's a small change, so it can go into a minor, but I don't think they reflect the actual change of the code itself.
The size of the mindset shouldn't be by the size of the change. It should be like
yeah, it's the impact on the client.
And besides, it's of course a mere guideline, so it's not like a set of hard rules. But the guideline, if like we agree on a guideline and pretty much everyone follows it.
It's better that everyone follows it. To like these kind of, if there are exceptions, they should be treated as such. And we should, it should never have like the definitions, like you're saying, they're pretty straightforward, right? So I think it would cause more confusion if people just don't follow them just because this is small, whatever. So it's better if everyone follows the same approach.
The idea is that just by looking at the version or knowing which number you're bumping, you can get an idea of what might have changed.
If something is breaking for you, for example, you can just check if there was a major version bump, and you probably identify immediately that what changes were made from a version to another, so you can pinpoint immediately what probably went wrong for you without knowing.
So that was versions. Any other questions before I proceed? Okay. So, release types. At Sybil, we categorize release types into 3 different types of releases. We have library releases, components, and product releases. I'll be going quickly through each and every one of these. So for a library release, we adopt the semantic versioning, which we've been talking about. When we come to choosing a branching model in Git, we stick to the GitHub flow, which is a simplistic flow. So basically, we'll have the master branch, which is your development trunk, where you commit, where you are merging all of your code. And here it's identified by the blue dot. And you have feature branches and bug fix branches, which are taken from the master and merged back to the master. So one thing which we recently tried to introduce is that the master branch would never be a snapshot version. The idea of this is to allow us actually to adhere to these guidelines that we've been talking about. If the master branch spends an entire month between one release and the next, for example, being a snapshot version, the version would never be indicative of what changes have been merged to master. So the idea is that every time we take a feature or a bug fix branch, in our PR, we include a change in the version number. And that change should indicate what changes are in that branch, pretty much.
Because one of the discussions was like, alright, so if we finish the feature branches, we just comment it immediately, like you're saying. And if we have multiple versions, it's not an issue. So we can have like 2.15 or 16. It's actually better that we just go ahead and commit, right, immediately rather than say waiting. Alright, I won't commit it because probably I have another change and another feature or another bug or whatever. Like doesn't come at any cost just to bump it up.
We shouldn't shy away from bumping the version numbers. I mean, they're there to indicate. I mean, we might maybe in a couple of years' time end up with a library 100.0, but what the heck? I mean, yeah. It will be the natural progression of things. You'll have a big repo, you're going to split it, it will become two smaller repos with versions less than 1. So they won't be stable. So basically, on each merge to master, we'll have a release version. Like this, master will always be supposedly stable, at least from a version point of view.
Does it test on console?
I will go through the console very soon. So basically, one additional thing that we should be doing is every time that we merge, so any of the blue dots, those are commits on master, we should tag them with the release version of the library. So basically, from source, it's quite easy. Every time you commit, you right-click on the commit, tag push commit. And who's using the Git bash, I'm quite sure you have an idea of how to push tags as well. So basically, take the version of the product, of the library, and just push it. Like this, it will be very easy to actually compare what happened between versions. A person who's looking at your library and decides to go from version 1 to version 2 can simply compare the two tags and get an idea of what changed. It becomes much, much harder without the tags.
So when you start your first piece of code on the library,
Excuse me, guys, can you please come closer to the mic? Only Clayton can we hear.
I can repeat the question if
Yes, please.
when you first start coding your library, you first thing you do is branch off, because else you'll effectively have a snapshot in master kind of.
So the question is, how do you start a library? How would it look? The branches of a new project. Pretty much, you would start from master. So you would have an initial commit on the master branch, which would probably include just a README or a skeleton of the project or an arch type if you generate it from some sort of template. And then you take the first branch from it, apply your first commit, your first real commit, and then actually merge it back to master. So initially you'll start with one commit from master. Questions? So, the next type of release, component release. This picture I took from the wiki, so at the end of the presentation there'll be a couple of references, a few references, so you'll be able to refer to this. So I won't go into detail into the GitHub, into the Git flow, how it works. So basically, for component releases, which are components that we actually deploy, we also stick to the semantic versioning, the 3-digit major minor patch. We use the Git flow, which is shown here. The development trunk, where we're merging all of our features and bug fixes, are the yellow dots, the develop. For these type of components, we keep the develop always on a snapshot version. All our features and bug fixes, we take them from the develop branch and merge them back to either develop or to release. If we have currently a release deployed on MFQA, on the QA environment, we will pretty much be fixing bugs on the release branch. So in that case, we would be creating bug fixes from the green release branch and merging back to the release branch. Anything which goes on the release branch eventually will need to go back to develop. So we either at the end of the entire release, we merge the release branch to develop, or for every bug fix that we create, we merge it both to release and to develop. So develop will need to stay updated. Otherwise, what we fixed in this release will actually resurface in the future release.
At the moment, that's not our process, right? So at the moment, if we have a bug in MFQA, we open a branch in develop, then push develop, then push develop.
At the moment, No. Basically, the question is if this is the current process that we adhere to. This is actually the current process. Was documented on CIA. I believe there was a presentation by Bjorn or Pete. So basically, the idea is if there is a component deployed on the QA environment, the fix is done on the release branch, because the release branch will be the code which is deployed on QA.
I think the only, like, correct me if I'm wrong, that right now what's happening in the release branch, we don't commit from release to release, right? Like, so we look at the diagram between the green dots. Correct me if I'm wrong, we still take a branch.
Yes.
Right? That's the only difference, but it's still on the release. So between the green dots, imagine there's a feature branch, and then you commit, rather than committing directly to release.
So let me repeat what Bjorn was saying. On the release branch, we don't commit directly. We pretty much take bug fix branches. We wouldn't have feature branches on release. So bug fix branches from the release and merge back to release.
The same bug fix branches also merged.
And of course, the idea would be that the same bug fix would be merged also to develop. But at the end of the release, when we actually merge, as shown here in the diagram, when we merge the release to master, we can also merge the release to develop. So both would work actually, but yeah. So that's master branch. It should always represent what's on prod. So pretty much once we are satisfied, or QA are satisfied with what's on the release branch, release engineering will take the latest version of the release and deploy it on production. As they do that, we usually merge this to master. There's also hotfix branches, what's here shown on the red dot. These would be fixes which are so urgent that they cannot wait for the next release. So imagine there's a release which is planned for next week or 2 weeks from now, but we cannot wait for that. So we basically take the code which is on master, we create a hotfix from master, we do some changes to the version, you'll see soon, and we merge back to master, and it gets deployed to production. Pardon? As far as I know, on PNCP we never had hotfixes. We had one. The question was whether we have ever had such scenarios.
I don't think so. QA always would want us to go through the QA cycle. Because that would mean skipping the QA cycle, right?
Yeah. I think in fact when we had it once, we already had put on a release on QA, so we couldn't deploy it on master, and we did the hotfix and then straight to prod.
So it seems more like the corner case, both for Sysibil and PNCP. Yes, yeah. Yeah, that's the fix here. So, each version of master, it gets tagged with the component version. So, like we said, the component release uses semantic versioning, 3 digits. Every time we merge to master, we should have a tag on the master branch. Also, since each component release would actually constitute parts or an entire product release, we usually also tag with the product version on master. So for example, just to give you an example, PNCP specific, if this is component 1.5.0 and the PNCP version is 4.2.1.1, we tag with both tags. So the blue dot will apply 2 tags on it.
So on the tagging station, we always do it on making, right? So we don't, for example, create a release from develop and the daily tag there. It's always when we actually merge to master, for example.
We, at least on the PNCP side, we usually prefer tagging on master. we might have RC cycles in between, which would only be tagged on the release branch, but whatever gets merged on master, the tag would be there.
What we do, so we go to QA, we tag it, and then if we do bug fixes on that, each one has a tag. And what we tag is only what goes to production where it gets tagged.
So we usually tag these as well on the release branch, the interim RC version. But then we're trying to work on some automation for these releases, and the automation, what it would do is it would merge the release branch to master. If there's a tag, it would delete it, and when it merges it to master, it would tag the merge commit itself. So basically, you get a...
But this would be only what would be pushing to production. If let's say, for example, you release a component and you need RC2, there is no point in tagging RC1 on master because it's not going to be on production. The RC2, which is on.
There wouldn't be a tag RC1 if we go through two RCs. There wouldn't be ever a tag RC1 on master. There would only be the RC2.
Our RC would be on the release. That's why we have different RCs. They take them on the release.
And the same thing is reflected in Jira from a release point of view. So in Jira, the VMs, they merged all the versions into the last version.
So the discussion is whether to tag on release branches or actually just on master. I believe the consensus is we usually keep tagging interim releases on release branch, but what the only RC which makes it to master, that is the only one which is tagged on master. The final RC.
For the tagging, you could have found out right that if we had on the release branch and then we merge, the tag would actually still be there because the tag is on the commit.
So that's why I said in the
deleting.
I will go retag and tag it to commit.
And why? What would be the difference?
It's much clearer. So the question is why, instead of leaving the last tag of the last RC on the green dot, we actually delete that one and tag the next blue dot. The idea is to only have tags of what went to production on the master branch. If you have to actually
because I think then you won't see it on the master branch, right?
You would see it because we don't do fast forward commits, but it will be somewhere branched off in a release which eventually got merged to master. It wouldn't be as easy to...
The release branches, then you just see a tag and you're not able to tell how the particle got to it.
The tag would be on the commit.
Release. Yes, but you won't, for example, in the network, you won't see the release branch anymore.
The commit branch.
It's just a tag floating in.
It was part of a merge.
I seem to remember that we used to think that tags would go up automatically to master once you merge, but it wasn't the case.
The merge commit is a new SHA, new commit entirely, so the tag would remain on this one. So if you had to just look at the master history, you wouldn't find the tag there.
Yeah, that's why you have to actually delete and create.
What we don't do, this side, we don't actually take two tags, like one for the product, one for the component, and one for the product. We just have a tag with the component version.
But the components constitute...
Can you repeat the question, please?
So the question is, on Sysibil side, they seem to have only the component version and not the distinction between component and product. Are they actually the same, the component and product?
No, they're not the same.
They're not the same.
So it helps us, for example, if we realize we introduce a bug in a specific version of the component, it helps us in order to backtrack to see which product version the bug was released.
What is that?
And in PNCP we have a lot of microservices as well, like the number of components is probably much bigger.
For us it helps us.
So tags are free.
Yes, but then when you're scrolling in the...
No, there are only going to be two, maximum of two, next to each other in the same comment.
For example, we have a slight idea of when a product gets released, because that's for PNCP at least it's pretty much monthly release cycles. But if it's a particular product, I would have to go and look in the release notes to tell you when this made it to production. But just by looking at the tag of the product, I would be able to tell you it was pretty much a month ago that was deployed on production or 2 months ago.
In fact, I think, I don't remember when, we were actually trying to use, not creating a tag for the product, we were trying to use to have that release notes repo, and over there you have the list of components, and if you go to, let's say there's a version 2.3 in our case, you would have a look, you'd have the list of components, what versions, and they would take you link to the component tag. So as to avoid having too many tags, and then you want to look at, let's say, I want to know what the product version 2.3 was used, so we don't have to go to the specific components and check each tag. It's going to be go with one page, in day 2.3 it has these versions, these component versions.
So what
Yeah, but usually it's the other way around, Mandy. Usually you're looking at the code, you see something, and you say, ah, in which release did this make it? In our way, you'd go directly to the tag. With your way, you'd first have to see the version, then go to the release document that says in which version was that released. And you'd have to go through the releases until you find that version, right?
In the case of PNCP, we actually maintain both. So you could start from the release notes and see what the component version, or actually look directly at the component repo and identify the product tag there. It's like the more a tag ultimately, like Pete said, it's free, and you could put anything in there. You could say before major relay, pretty much. It's just anything which would help you identify a specific commit. It's fine as a tag. Of course, the product and component tags are something that we like adhere to. It's like
well, the fact that it's like, yes, big tags is not a problem, but it's just like they're the same. Like they're pointing to the same commit. It's the same tag, just a different name.
It's multiple tags pointing to the same commit. Yeah, but both give you different information. I mean, like one of them is the component release, the other is the product. Both might be valuable pieces. They're like an index. So multiple indexes can point to the same thing. Questions?
No, I include both the product tag and the component tag in the same tag. So it's just both.
So
I mean, from a visibility point of view, you get both information with the single tag.
I believe that happened for us at times, that we had almost separated list of tags and the same tag name. Honestly, I don't like it much. I'd rather have 2 pointers to the same commit than one tag name with meaning multiple things.
Because that's what Mandy is saying, that you go on this bucket and you have sort of this huge list of tags. This was happened.
Yeah, so you'll end up with a lot of tags.
I know.
I mean, like, you'd half them if you do as you like. It's a matter of person and space, I think, so it's not something that should be hard-coded. So, product releases. The version of a product release, I won't spend much time on this, contains 4 digits. So A, B, C, D, this is documented in the wiki. A is the major, D is the minor. These 2 are the business-friendly digits. Let's call them like that. So if PNCP is being marketed, a new feature is being marketed, for example, they will say PNCP 4.2 will have this. This is what marketing and sales and the outside world sees. Then there's the C and D digits. The C is if we do a hotfix directly on production, it is usually 1 unless we have a hotfix. So in that case, if we have PNCP 4.2 on production, it would be 4.2.1, and this will become 4.2.2. No, we usually start with 1 for this as well. And the candidate number also, we start with 1, which would mean if we have just 1 release on QA before we go to production, we will release something like 4.2.1.1. The last digit will be 1. If we have multiple RCs, nothing would be changing in the major, minor, or hotfix, just the candidate number. So, a bit of a mentality shift. What's the status quo? We all have snapshots, versions. Why should we update a dozen POM files just to get a minor change in a library? Snapshots are easy. You'll get your changes automatically. It's an in-house library. We all know what we did in it. Why should the version tell us what's in it? And we are not releasing the product X. Why should we release this library? We release it when we have to. And the idea that we just should be concerned as developers with developing and release engineers with releasing. I mean, like, ultimately it is the developers themselves who know what changes are being introduced into a feature or a bug fix branch, so they should be the ones deciding how to name it. It's just a name, the version, ultimately. So, the benefits of using snapshot versions. Valeria's question. So basically, in snapshot versions, you get to do less updates to your build configuration files, being Maven, Bower, or NPM. You are always getting the latest version of the dependencies. Yay, bleeding edge. And you only release when absolutely necessary. So you don't have to go through a release unless it's absolutely necessary, which is probably the product release date. In brief, you get to do less work initially. The drawbacks of using snapshot versions. So the builds are not always reproducible. You might get a build which is working fine now. You don't change anything in your local codes, which you are in your feature branch, for example. All of a sudden, your local feature branch starts failing. What could have failed? A dependency change. It was snapshot. It means it can change anytime. So, what's even worse, you will get no notice of that. So, you will have no idea what changed. Your best bet would be to go on some Slack channels and ask about it, because it's not a change you introduced. You will not have any idea of what changed. Of course, it makes it harder to understand what changed. So if you are working on a component which has 20 snapshot dependencies, good luck identifying which one of them it is. It makes it harder to use proper versioning standards. I'll give you a concrete example after this slide. And of course, when the product release day comes, you actually have to do a lot of work going and releasing each of the snapshot dependencies. Questions? So, the scenario. Imagine we have a library, or it could be anything. It could be a widget, for example, which we package as a web component. We have a commit, where we bumped the version. So we just took a 5.0.0 release, and we're going to work on the next version, which we decided to name 501 snapshot. Another commit gets added, and we introduce an on-breaking fix. The version 501 snapshot, although it has the snapshot in the name, is still indicative that this is a bug fix and nothing broke. Another commit gets merged. Of course, the version doesn't need to be bumped because it's snapshot, so people will be taking the change automatically, but it's a major, so it might affect other people. Then the release date arrives. Basically, the person who needs to release that project will basically end up in a dilemma. He will have to decide whether to just remove the snapshot version and leave it 501, or actually bump it to 600, and will end up with an orphaned release, 501 snapshot, which never got a release. So, as you can see, it will make it harder to actually adopt the versioning strategy.
We've had worse cases where, for example, so on commit 3, someone will go update the version to 6 of snapshot. But then there's another project depending on 501 snapshot. We release 6, version 6, we come to release a component that's using 501, and it fails because it's depending on a snapshot dependency. So we can't update that to 0.26 because we know in 6 there were breaking changes. So we need to then revisit 501 and release that. So a headache.
Was the scenario clear on the call? Pete was describing. Yep.
So it makes sense to release the 501 before?
Yes.
Correct. Yep.
Before any change in the version release.
So you think, so that's the question there. It doesn't make sense if you type there's a change or if they're really like version of each game. Why is it
So for develop, we usually keep, so the question is whether we should do the same with component releases as well, rather than just libraries. It would add a little bit more work if we have to release every time we merge to develop. However, there are some discussions on what we might do to actually help with this. We usually don't depend on the version of a microservice. Since it's just a deployable, we don't include it as a dependency. It's not a reusable piece of code, it's just a deployable. However, part of it, like we have microservices clients, for example, those have the same version of the microservice, and those get packaged as dependencies and included elsewhere. So there are some discussions on how to actually tackle this. I won't go into that because it hasn't been yet agreed by everyone.
I'm not sure why that question just has to immediately upgrade to the next version and the phone for future development. Was that the question?
Every time you merge a feature, or
and you really doesn't take the bulk of the version immediately to run on snapshot and you do the exception and then you like in GPR because sometimes you just work on exception version.
I think the idea would be, if this is a deployable component, it of course has an API. So if we do a change to an API, we should ideally release that API and start working on the next fetch version, the last digit. But there are still...
Hey, Clayton.
Yes.
Just a question for commit 2 and 3. What is the branch where change is committed? Release branch or develop branch or some buckets branch or something?
The scenario is a library, so it's pretty much a GitHub flow which would only have master. So imagine having multiple feature branches. The first one gets merged, version is 501. Second feature branch in commit 3 gets merged, and it's a major change.
So the master branch, and you just said in previous talk that we do not have snapshot versions for libraries. On master is always a final version, and you're creating branches from master branch, and after you're sure that everything is correct, you will increase version and merge it to master, if I understood correctly.
And this is exactly the reason why that is being enforced. But before it wasn't like that. This is quite recent. I mean, like, I think we've been adhering to the idea of releasing every feature branch or every bug fix branch. It's maybe the last couple of months. So this was the kind of scenario that pushed us actually in that direction. So basically, they should give an idea of why we're actually going through the afferent extra work of releasing every branch.
Okay, thanks. It's clear now.
Okay. So the question was whether we should be doing, Michaela's question, whether we should be doing the same for component releases as well. At the moment, we don't.
We're working on a snapshot, wait, and then release, and then release.
I think personally a good suggestion is that since the component has an API, you make the major minor describe the state of the API, and the patch is just used. So if you're adding it would be a minor.
You're not breaking backward compatibility, you're actually adding features.
So pretty much, let's say we have a component that is 5.2.0, for example. As soon as we introduce the API change, we release 5.2.0, and we start working on 5.2.1 non-developed. And any changes that we do, they can go on 5.2.1 snapshot, so long as they don't modify the API. If they modify the API, we would make it 5.3.0 or 6.0, you know, and we can still work on snapshots. But then, unless the API changes, the microservice client wouldn't change. So you can pretty much keep depending on the same client. So you don't have to update the client in a bunch of POM files. That's just a suggestion, but so basically one thing which actually happened in this scenario was that after commit 3, anyone who was depending on 5.01 snapshot got a breaking change without changing their code. So their code would have broken. So, us, this is Bill, as software maintainers. How can we actually minimize how costly it is for our users to use our software? How can we facilitate the use of our software? Basically, one thing which will help the maintainer rather than the user is avoid maintenance branches. Another one is aim for high cohesion. I will be going through all of these in more detail. Keeping your code lean and refactor often, but break rarely. Ultimately, make proper use of semantic versioning. And be nice. I'll tell you more about that. So why should we avoid maintenance branches? It is pretty much more a concern for the software maintainer because it will take him more effort to maintain the old branches. We used to have a lot of these in the past. We used to maintain multiple versions. Hopefully now we're reducing the reliance on maintenance branches. And every time you need to do a fix, you need to merge it to not just one branch, but multiple branches, which will add more work and will make the whole thing confusing. Maintenance branches, imagine if, for example, you have a library which is compatible with both Spring 3 or Spring 4. And you need to maintain both versions. Anytime you do a change, you will have to include your change in both branches. Imagine you went through, we're packaging now web components. Imagine you have web components which are compatible with Angular 1 and Angular 4, and you need to maintain both of them. It's not ideal. It will add work.
How would you, in such scenarios, where would you, for example, take with the release? On the actual branches, not from...
The way we model this around GitHub flow is we keep multiple master branches. So you have a master and master 0x, for example. Of course, the master would be a version bigger than 0 point something, and the 0x will never go to 1 point something. It's something that should always be treated as temporary and as a last resort. However, there are ways actually of good practices which will avoid having to keep maintenance branches. I'll be going through them soon. So, low cohesion. So basically, cohesion in software means how related the elements inside a module are. So basically, we should always aim for high cohesion, and these are some of the issues which we will have when we have low cohesion. So pretty much all sorts of unrelated logic is bundled in the same library. All this stuff that will be imported will be imported in a bunch of different places. So imagine you have a library which you call the very original name common, and it contains everything. Every person who needs any one of those things will include all of your things. So ideally split things. Even if we go into web components, if we try and start bundling widgets into web components, we should try to categorize them, make logical groups out of them. Maybe, I don't know, the ones which are categorized as selectors, we put them into a single bundle. Or maybe a widget, a bundle per widget, for example. Or the ones which are selectors, we put them into a single bundle. The ones which are labels or text boxes, we put them in another selector, in another bundle. It will help in the future because basically you might actually decide to use a selector from a particular library, but implement something in-house for a label, for example. So if you don't have both in the same bundle, it will help you. Only a fraction of the functionality will ever get used, but you will still get all of it. And you end up with a monolithic library, a library which contains everything. This can cause issues with conflicts, so you might end up with multiple implementations of the same widget, multiple versions of a dependency. So what's the solution? Split into multiple libraries. Questions? Keep your code lean. So basically, dependencies which are used by your project are also going to be included with whoever is using your library. So think twice before adding something to your library, be it a dependency, be it a new class. It's good that you keep adding, but sometimes you might realize that your library has 10 things, you're adding an 11th one, and you realize that 5 of them are related, another 6 are related, make them 2 libraries instead. Moving code is quite easy. I mean, we have toolings, it will help you, so. And of course, make use of proper dependency scoping mechanism. I won't be going into detail, but basically, does your library actually need that, or is it optional? Is your library usually assured that the library will be provided? Do you need it to compile, or just to compile, just for tests? Do you need it only at runtime, or do you actually have classes which refer to it? I'm not very familiar with how JavaScript handles dependencies, so I don't know about scoping there. So basically, you might end up with multiple dependencies which can conflict. So, refactor often, break rarely. To actually make it easy for users of your software, try to keep your library in. So pretty much refactor even for maintaining the library, but try not to break the API. If you actually break the API, you know how to indicate that you introduced a change. So basically, use semantic versioning. The API of your library, the version will mark whether it is stable or not, what kind of changes you're introducing, etc. So basically, in other words, be nice. So how can you actually be nice to users of your software? Use good naming conventions and adopt the principle of least astonishment. So if a method is called add numbers, it shouldn't multiply numbers, so provide good documentation. I think it might be easier said than done, but actually documentation is good. So us as a software user, not maintainers, how can we minimize the cost for us? And there will be the answer of how to avoid maintenance branches. Basically, these concepts will apply for both our software and third party. So us as users of our own software and third party software. We should aim for low coupling. We should keep our code lean. So basically, are we talking about us using in-house or us using third-party software? Should we bother? We should treat them the same way. So we should not say this is in-house, we know what's in it. We should trust the versioning. We should trust that we only depend on release versions and not snapshots because it's internal. So treat them in the same way. It will avoid you pain. So it also gives us the benefit of scalability of use, which means if a project is currently using a lot of dependencies and it doesn't make sense to split it into multiple ones, of course, if you treat your in-house code like third-party code, you have a better understanding of what is changing. So if you have a lot of dependencies on third-party libraries or in-house libraries, it will definitely grow to an unscalable mess, pretty much, if you depend on snapshots. So, low coupling. coupling is basically a fancy word to describe when two particular modules are related to each other. So basically it's a measurement of the relationship between the modules. A way to make it easier for you to use third-party libraries is, first of all, why do we use third-party libraries? There's a piece of code which you don't want to actually implement yourself. There's a well-known library which does it. Let's use that one. However, if you actually depend too much on that code, so imagine it's a component, you define an API, you define a widget, you define that you expect some classes to be defined, for example, and these classes are actually the same ones that are being used by Bootstrap, for example. You can do that and rely on Bootstrap, but if you have to actually change from Bootstrap to something else, it means that you will have to refactor all your styling. However, if you define your own classes and then you provide some sort of scoping to actually extend the classes of the library you're importing, it will make it easier. So basically, if you actually need to swap a library, if you adhere to this standard, it should help you a lot. It should be a matter of replacing a dependency, possibly. And of course, whenever we come to update something, if we don't expose the inners of that library everywhere, if we don't leak that implementation detail everywhere, because a library dependency is an implementation detail pretty much. If you don't expose it, it would be easier for you to update the version of that library. It would be very localized. So in the case of styling, like I was saying, maybe you could scope the classes you are importing, somehow make them contained. So keeping your code lean. Think twice before adding extra dependencies. Sometimes you think there's a constant value, you need it's defined in a library, you actually need an entire library for a value. Same thing for classes. Is it worth actually redefining that class or pulling an entire web component for one CSS class? Making use of proper dependency scoping mechanism, like I mentioned. And thinking of how the dependency might conflict with other things you have.
So if you want a constant, I know it's just a constant in this case, but do you define it in somewhere else, or what's the best use? I mean, a constant somewhere else, or?
Of course, one of the unique keys of software would be reusability. So we should aim for reusability. Now, reusability doesn't mean have a library, put everything in it, and use it everywhere. That is one way to think of reusability, but ideally, and the worst thing you could do is actually redefine the same constant in multiple places. A good thing to do it would be to gather enough functionality which is related into a small library and only pull that. So I'm not saying that we shouldn't be reusing the same.
Quite simple that it can be confusing. I mean, it can be confusing as in to the extent of what the library, what the size of the library is. Like if I'm only using a constant, or probably if you're using that constant, you're probably using something related to that constant, of course. So in the same package, you'll probably be using the same either logic or something else from that same library. I mean, that's why it's what it is.
If the maintainer of the library adheres to the guidelines that we've been going through, hopefully there wouldn't be, a monolithic library which also includes constants. So you shouldn't be afraid to include it. But questions? Sorry, I've been running a bit through the last slides. But
on the scoping.
Yeah.
So by default, I think this is the compile, right?
By default, maybe you just compile it.
And what benefits do you get from?
So the question is, what benefits do we get by using proper dependency scoping? Imagine, for example, you have a library which you should not be using for compile scope. You only need it for tests, like for example, FODAM or a mocking library, for example. If you included only for test scope, that library wouldn't be included everywhere that you are including that library sensitively. So the benefit of runtime, imagine something like a connection pooler, for example. So BoneCP or Hikari. If it's something like that, that's something which only has a function at runtime. A connection pooler would not give you any benefits to have it at compile to refer to any classes defined within the connection pooler. But if you actually define it as compile scope, you might be tempted to actually reference some of those classes. So your class path would be littered with a bunch of classes which you really shouldn't be using. And what stops you from actually doing a Ctrl-Shift-O import and getting one of these? If you have it at scope runtime and you want to move from BoneCP to Hikari, if it's scope runtime, it's as easy as removing one and introducing the other. You have a guarantee that your build is not referencing anything of BoneCP.
Probably there's a bridge which is actually calling or using directly the actual move. Yeah. Which is not yours.
Then there was the concept of optional dependencies. Just to give you an idea, I believe Spring Data uses this to include multiple versions of Hibernate. So they run tests against multiple versions of Hibernate, but then they make it optional for you to include them. Now, of course, if you use Spring Boot, you will get the BOM, you'll get like an opinionated view of what Hibernate version should be using, so you would never include Hibernate yourself. But actually, the way that Spring Data would test against multiple implementations of Hibernate is by making it optional, so it works. Another thing which would also be beneficial to make runtime, for example, is a logging implementation. Ideally, we should always log using a facade, like a Telefforge API, and we should never use the logger directly. To avoid that we actually, by mistake, include one logger class instead of the other, make it runtime. It won't be available. Yes. It will facilitate. I mean, they're not mandatory to use, but when it comes to upgrading the version of a library, imagine the API of Log4j changes, for example. You shouldn't be bothered about having to change your code if you're not using it. So, questions? So basically, for reference, I'm including here a few Maven commands which can help you with actually some of the things we've been talking about. If you need to release a component, there's a versions plugin, especially if there's a project with a lot of submodules. It can be error prone to actually go through each and every one of them, so there's this plugin which you can use. If you need to have a look at what dependencies you have in a project, you can use dependency list or dependency tree. And you can also filter by a specific dependency which you're looking at. Of course, the slides will be available, so feel free to refer to them later. And dependency analyze, it will let you know which dependencies you have which are not used. It will let you know what libraries you're using but you're not defining yourself. There's a lot of material on the internet. I'm quite sure you'll be able to.
Good way to identify what should be runtime or
and some references. References are all from our wiki. So we have the Git page where we describe the Git flow and the versioning, and the release versioning where we describe our versioning strategy and something on Maven as well. That's all I had. Okay. Thank you, guys.
Thank you. Thank you.
Bye bye.
Bye.